Alright, this is our Chapter 14 test review, and the first question asks us to graph y equals negative cosine of 2x. First job is to find the amplitude and the period. This is similar to what you did for your quarter project. The amplitude is the absolute value of the number in front of the equation, and since I don't have a number, I assume it's a 1. So it's actually like a negative 1 there. And so the amplitude is the absolute value of negative 1, which is just 1. The period is 2 pi, always 2 pi, divided by this number here, whatever is multiplied by x. In this case, that's 2. And so 2 pi divided by 2 is just pi. So now I can go create my x and y axis. I know I'm going to go up to 1, and I'll go down to negative 1. I'm going to go out 4 marks to the right, and 4 marks to the left. The fourth mark I'll label pi. Remember that halfway, which is the second mark, is half of the fourth, so half of pi would be pi over 2. And then I'd cut that in half again to get this first mark, and that would be pi over 4, because half of a half is a fourth. And then we times this first mark by 3 to create the third mark, which would be 3 pi over 4. And over here, obviously, we have the same things, but negative. I'm going to be a little lazy here and not write all of them. That's okay. When I go to graph the cosine, normally cosine starts up here at the amplitude, but because of the negative in the problem, I'm actually going to be upside down. So instead of starting high and coming down and going back up, I'm going to start low, come up, and then return back to my starting point. I'm going to need to mimic and follow that pattern back to the left. You should have 2 cycles of this wave for you to be done. Your graph should look something like that. Notice it's not a bunch of sharp, jagged edges. It's a curve. So kind of keep that in mind when you produce your graph. Number 2, y equals 3 times the sine of pi x. Same rules here. Amplitude is the absolute value of that first number, which would be 3. And the period is 2 pi divided by whatever number is right there. In this case, that's pi. And 2 pi divided by pi is 2, because the pi's cancel. And I create my little graph. I'm going to label that 3, and that negative 3. Go out 1, 2, 3, 4. I'll label that 2. 3, 4, negative 2. Half of 2 is 1. Half of 1 is 1 half. 1 half times 3 would be 3 halves. The sine wave starts right in the center. And typically, if it's a positive sine wave, it's going to go up first. This is a positive sine, so it's going to go up, center, down, center. And so we get this sort of curve. This gets people into trouble when they go backwards. They tend to, there's some people that make a reflection the wrong way. Just remember, we're following the pattern. This thing is on its way down, so I've got to head down, then back to the center, back to the top, and back to center. And so it should look like the same wave is repetitive. You see the same exact curve on both sides. All right, and then we're going to go to number 3, which is our tangent curve. Y equals 2 tan, don't need that, 2 tan of x over 2. Now, I'm going to have to point out right now, this is, think of x over 2 as 1 half times x. We're going to have to think about it like that, or we're not going to be able to do the period correctly. There is no amplitude for a tangent curve because it's vertical, it goes up and down forever, but the period is not it's not going to be 2 pi divided by b, rather it's pi divided by whatever that number is. In this case, it's 1 half. Okay, taking that 1 half. Now, it's important to understand tangent's different, so it's not 2 pi divided by the number, it's pi divided by the number. And in this case, when we have a problem like this, we keep switch flip. So we'll have pi times 2 over 1, which comes out to be 2 pi. And so if I produce a graph, I go out 4 marks, 3, 4, label that 2 pi, which would make halfway be pi, and half of that would be pi over 2, and that times 3 would be 3 pi over 2. Go out the same way to the left, label that negative 2 pi. Now, these graphs, these tangents, they are different. They're the ones that have a break in the graph halfway. So at the second mark, we should create a vertical asymptote on both sides. And then your curve is going to go right through the center, and because this is a positive tangent, it should go up on the right. If it was a negative tangent, it would be down on the right. So because it's up on the right, it's down on the left. We create this type of curve. Now you got to show me at least 2 cycles, which means I need to go out further to repeat the pattern. But the good news is everything's in groups of 4. So from this mark, the asymptote, I go 1, 2, 3, 4, and I'll draw another vertical asymptote. Right in the center is my crossing, and I get that. There's 2 cycles, but I like symmetry, so I'm going to go 2 more this way. Put it right in the middle, and zigzag my way through. And there's our 3 different curves you're going to be asked to graph. All right, number 4, we're starting into these trig identities. I'm going to tell you right now, you need the trig identities in front of you. We have cotangent, over cosine. This is not Pythagorean because it's not squared and there's no pluses or minuses. So I'm going to turn everybody into sines and cosines. Cotangent can be replaced with cosine over sine, and that's over cosine. Whenever we have problems like this, it's a keep switch flip, and I really need to flip the bottom, so I'm going to make the cosine be over 1. So I keep the top, cosine over sine. I'm going to multiply by the flipped version, which would be 1 over cosine, and cosine cancels cosine. That leaves me with 1 over sine, which on the definition chart is cosecant of x. There's our answer. If you have questions, this is where you come back, and we're going to talk about it in class. Ask me those questions, but hopefully you've done some of the work along the way. We have tangent times sine times secant. Again, I'm going to turn everything into sines and cosines. Tangent is defined as sine over cosine. Sine is fine. I like that one just fine. I'll put it over 1 just so I see the fraction structure everywhere. And then secant is 1 over cosine. Now notice, other than these 1s, there's nothing that would cancel. So I just multiply through the top, and I get sine squared over cosine squared. Well, I learned earlier that sine over cosine is tangent, so sine squared over cosine squared would be tangent squared of x. And there's our answer. Number 6, guess what? We're going to do a Pythagorean. It's tangent squared times cosine squared plus cosine squared. Well, it's Pythagorean except for this part right here is the middle of a multiplication. It's got to be dealt with first. I'm going to turn everything to sines and cosines. Tangent is sine over cosine, and because the tangent was squared, those would be squared. And it's times cosine squared over 1. Of course, I have the plus cosine squared. I haven't touched that. Okay. Well, here I notice that a cosine squared is going to cancel a cosine squared. So this would be, over here on the left, I have a sine squared. I've got plus cosine squared, and that looks very Pythagorean. If you look at the Pythagorean identities for that, it's equal to 1. All right, just got a couple more. 7 and 8, we're going to start doing some basic solving. So number 7, 2 cosine of x minus root 2 equals 0. We need to get cosine alone, so we're going to add root 2 to both sides. We get 2 cosine equals root 2. Now we didn't put that root there, so we don't have to have a plus or minus. We divide by 2. Cosine of x equals root 2 over 2. Now you need to give me the answers for when is this true. This is about going to the unit circle, okay, and finding the places when the x is root 2 over 2. There are 2 places, okay. Our 2 places are pi over 4 or 7 pi over 4. Now I say to answer in general form, so that means we add 2 pi n to both of those answers. Okay. And then number 8, similar but with a tangent. 7 tan of x minus 7 equals 0. I'm going to add 7. 7 tan of x equals 7. divide by 7. And the tangent of x equals 1. Well, if I go back to my unit circle, and hopefully you've written down where the tangent of x is equal to 1, that should be at 45 degrees, which is pi over 4. And if you want the other location, you'd follow your way around the circle. You need another place where the y and the x are both negative, and that should be at 5 pi over 4. And we're going to add 2 pi n plus 2 pi n. Okay? Basic solving, and then using your circle to finish the problem off. Number 9 and 10 are our sum and difference. So cosine of 195, and then number 10 will be sine of 75. So the first thing I have to do is rewrite this as an addition or a subtraction. I'm going to do the cosine of 45 plus 150. And down here, I'll do the sine of 30 plus 45. That's important. These angles are angles that I know exist on the circle. So I'm using numbers that I know are on the circle for my A and my B. A and B. Now hopefully you wrote down your cosine and sine sum and difference formulas. For this problem, for the cosine formula, it's the cosine of the first thing, which is 45, times the cosine of the second thing, 150. Because this is plus, the cosine formula says to use a minus. Sine of the first thing, 45, times sine of the second thing, 150. So the cosine of 45, looking at my circle, it is the x-coordinate at 45. That would be root 2 over 2. And that's going to multiply by the cosine at 150, which should be negative root 3 over 2. It's going to minus the sine at 45, which is root 2 over 2, times the sine at 150, which is 1/2. That should give me negative root 6 over 4 minus root 2 over 4. We just multiply the top. And to combine these into the same fraction, it would be a negative root 6 minus a root 2 all over 4. Similarly, for the number 10, for the sine, it's the sine of the first 30 times, sorry about that, sine of the first thing times cosine of the second thing, 45. Now, because this is plus, the sine rule says we're going to add. We're going to stick with that sign. And now we're going to do cosine of the first thing, 30, times sine of the second thing, 45. And so right here, the sine of 30 degrees is 1/2. The cosine of 45 is root 2 over 2, plus the cosine at 30 is root 3 over 2, times the sine at 45, which is root 2 over 2. I'm pulling all of these off that unit circle. If that doesn't make sense, you need to come and chat with me and we can walk through it. Root 3 times root 2 is root 6 over 4. So my final answer would be root 2 plus root 6 all over 4. And no, you cannot add root 2 to root 6. They're not like terms. All right, that's it. Whole thing. Good luck, and we'll see you in class.